Harvard would be glad to do it for you.
The fourth speaker today is Charlie Hale. Charlie is a policy analyst. There's a policy analyst at Google. He works on public policy and government affairs for Google's geo products, including his Google Maps and Google Earth, and Google X, which includes the self-driving car project, and Google Glass. You guys may have heard of some of that. There aren't too many concerns associated with that. He is also co-founder of the Global Health Corps and a member of the advisory board of Envea. And Charlie is going to be talking about, the work that Google's doing in geo, and also a fantastic study that was done on just sort of the economic value of geospatial information, and he is to be commended for helping to put that together. So, Charlie?
Thanks.
Charlie, are those Google Glass?
I have Glass with me if people want to see it afterwards. My brother is guarding them up there. Thanks. I just want to thank Kevin, first of all. He's been thinking about these types of issues for much longer than most people in the room, as has Mark Brender, who just texted me and said he's watching live, which is a little creepy. Mark, hello, through the camera. But Mark kind of made this whole space possible with commercial remote sensing. So, where is... I also want to commend the CGA for having the foresight to work with Mark on this, or work with Kevin on this issue. I think it's very important. So I'm going to show the only non-geo slide I think we've seen to date. This is my best friend. I recently got married 6 months ago. And my best friend was speaking at a conference in Tulsa 2 weeks ago and told a room of 1,000 people to tweet at me. And so all of a sudden, I was sitting at Google at my desk, and all of a sudden, 100 people in Oklahoma tweeted at me, and I had no idea what was happening, and I was completely surprised. So I want to get him back. So this is Andrew. He recently got engaged, so if you want to tweet at a random stranger and say hello, I'm sure he would appreciate it. So I wanted to first talk a little bit about how Google is thinking about geo. I think we've been working on geo issues for a long time. Obviously we're thinking about kind of the public policy framework around the products that we've built. Recently, within the last couple weeks, you may have seen the government of India has been in discussions with us around an event that we held in India to encourage what we call citizen cartographers, so folks to map their own hometowns and communities. And it's a way that we kind of build a lot of our map products as this kind of user-generated data. And the police in Delhi were concerned about the way that map data could be kind of used for national security related issues. So we are in deep discussions with the police department in Delhi. This apparently is a graphic that Google made, which I think is kind of strange. Know where the food tastes like nowhere else. Doesn't really make any sense. And I also, I think that there's reason to be optimistic about the way that governments can interact with the private sector. The other project I work on is a self-driving car, and we really got our start because of a government program. DARPA said, can anyone build a self-driving car to drive across the Nevada desert? And the team that did that at Stanford and Carnegie Mellon then came to Google and built the Google self-driving car, and we really couldn't have gotten that start unless the government had put out this moonshot challenge to academia and the private sector. So I wanted to quickly start about why I love maps. Not only is our dad a geography teacher in Maine, 7th grade, and my sister works at National Geographic, but I also have moments like this one that makes me kind of glad that I work where I work, which is a gentleman in Australia who, for 25 years, he was estranged or separated from his family in India. He fell asleep on a train in India when he was 8, got adopted by a family in Australia, and 25 years later used satellite imagery, digital globe imagery, I'm sure, using Google Earth to kind of retrace his steps. He found a train station in Google Earth that looked familiar to him. He followed those tracks to a town and then took a plane to that town and found his family, found his mom. And stories like that, I think, are important to kind of put all the work that we're doing into context. So where we started, this is the first version of Google Maps. We actually oriented the world around the US and the UK, which is a problem that map makers have made throughout the centuries. And a bunch of Germans actually got very angry with us. So it's a good lesson to not anger German users. So we reoriented the map and started kind of building it out from scratch. One thing that we really rely on for our data is MapMaker data, which is user-generated data. This is Islamabad, Pakistan. You can see it started blank. And then some students at the university in Islamabad started filling it in. Went from being blank to being detailed and useful. I think it's a pretty powerful example of how users can really contribute to our kind of collective mapping knowledge. Oops. Sorry. So at this point, we've mapped 200 countries. Most of the data is either what we call ground truth data that we've developed. Much of it is MapMaker contributed data from users. There are a few countries where we've had to work with third-party data companies. And then we had the last holdout was North Korea, which 4 months ago we finally launched. And so this was North Korea originally, and this is Pyongyang now. So kind of the last blank spot on the map has been mapped by us. And just to kind of stepping beyond mapping, we think of geodata as being kind of integral to a lot of things that we do at Google. So it's not just mapping, it's also analytics. It's helping website owners understand where their traffic is coming from. It's helping us target more relevant ads. It's helping make search queries kind of locally relevant. So when you put in the weather, it can tell you that the weather in Boston is 60 degrees and not the weather in San Francisco. This is also a pretty interesting, we haven't launched this yet. This is a preview of something that we're working on using the Landsat imagery that Nancy mentioned. But this is looking at 30 years of Landsat, or 40 years of Landsat imagery. This is in Dubai. We did these kind of time lapses that we've been working on. This is Las Vegas, which I think is really powerful. So you can see, I think that's Lake Powell, right? And Las Vegas expanding out, water depleting. Yeah. So I think, again, as Nancy's organization works on, many of our other folks in the room understand the intrinsic power and value of mapping and understand that we need satellites like digital globes and many others to be able to see this type of imagery. One other thing I want to talk about beyond mapping is what we call Earth Engine, which is our ability to use that same Landsat imagery to kind of algorithmically analyze a massive amount of data very quickly. So this is imagery we've taken from the Amazon. We were able to see how deforestation progressed over the last 25 years. And that's really something that you can only do with remote sensing. And we've been able to kind of use Google's massive servers to crunch all of that data and be able to kind of say algorithmically there's something going on in this location. So we actually partnered with a native tribe in the Amazon who, when our server said there's been a change, our algorithms picked up on some deforestation happening in a certain part of the Amazon. This tribe then went to that area, used Android phones to actually report and confirm that there was illegal deforestation going on, and then we could publish that to the world and kind of shine a light on something that was illegal and bad. This is Street View Amazon. This is my favorite image of a frog that jumped on the camera. And it's really going beyond the things that we can do now and thinking about what's the future of geo. How can we kind of make geospatial services and technology better? So this is kind of moving beyond the traditional relationship of between Google and its users of putting in a query and expecting to get that coffee shop back that you've queried Google for, and saying, we think we can suggest something that will be useful proactively. So the kind of the kit model I talk about. Okay, Glass, where is a coffee shop near me? Or using Google Now saying, hey, Charlie, we know you have a flight from San Francisco to Boston. You should leave now, which is very important for me, as my wife will tell you. I miss many flights, as has my brother. So I think we're starting to see some of the more futuristic applications of geo that are pretty exciting. Not only being able to tell you that your flight is coming up, but then giving you directions for how to get there. And the navigation aspects of glass are pretty powerful. But the thing, I think beyond what Google has been working on and beyond how we see ourselves contributing to the future of geo, I think what's more powerful is thinking about how other people are going to contribute to geo. So there's this great story I like to tell about a guy named Paul Rademacher who, when Google Maps was first launched, he hacked Google Maps. He took the code base, mashed it up with Craigslist, and then created the first ever mashup, or the first ever API, which was a site called PadMapper that took Google Maps, overlaid apartments in your area if you were trying to find an apartment, and was this tremendously useful website. But the Google Maps team had this dilemma of, should we sue this guy for hacking our new website that we just launched, or should we hire this guy? And fortunately, they decided to hire Paul, and that was the beginning of APIs. And I think Google Maps, if you take all the other top 10 APIs and combine them, it's the Google Maps API is still larger, and more people interact with Google Maps through another site than through maps.google.com, which I think is pretty powerful. And it's a testament to how, if you open yourselves up and let other people do things with your technology, they're going to do things that you've never anticipated. Both useful like this and inspirational like this. The Sumatra Eyes on the Forest project, which is a World Wildlife Fund and I think Natural Resource Defense Council project that looks at deforestation in Sumatra. Another API example. And then finally, I just wanted to end on, this is something that, wow, that's crazy. Okay, we wanted to kind of take a step back from what's Google's role in the geospatial community and what is the geospatial community to begin with. We wanted to understand what the industry was, and we know there's this intrinsic value to geospatial technology, but we have a real desire for data to back that up. And we wanted to start with the economic lens. So what actual economic value are things like geospatial data providing, not just for the industry, but for the broader US and global economy? So a study that we worked on with a company called Auxera, economic consulting firm in the UK, and BCG here in Boston, was looking at what's the size of the industry, and then what's the industry's impact on the broader US and global economy. And their findings were pretty interesting, I think, for groups like Keith's organization and many others. In the US, it's at least 500,000 US jobs are somehow attributable to geospatial technology. But the more interesting stat, I think, is looking at what their impact is on other kind of traditional sectors of the US economy, so things like trucking and logistics, things like retail, and they found that $1.6 trillion of US revenue is somehow driven by a geospatial technology. So they interviewed CEOs and VPs at different companies and said, how much of your quarterly revenue is attributed to your employee using GPS to get to a job site quicker, or using a team of geographers to figure out where to put your next store. And that number is pretty large. And on the cost saving side, they can spend a lot less money on gas, 1.1 billion hours of travel time, which is about $5 billion of fuel savings. That's tremendously valuable to companies. And we're seeing more and more companies starting to use geospatial technology, and if they don't, they kind of lose the competitive edge that companies who do have. So the last example I like to think of is that, going beyond just the how do I find a cup of coffee near me, and knowing that in some cases that company, maybe Starbucks, actually has a team of geographers that analyze geographic data and demographic data to figure out that Starbucks location should be where it is, and that billboard that you're seeing on the highway should be there because it knows that you're their target audience and that you're driving by that intersection every day. So that's the kind of economic value that we wanted to really quantify, and I think it's pretty powerful. This is a case study that we did on Boston in particular. Things like smarter transit, bike sharing programs, civic. I think the woman from MIT can probably speak to this better, but programs to report potholes and to show you what time snowplows are coming through. I think all of those geospatially driven technologies are pretty compelling. And I finally just wanted to end on this example of India, of we really need to understand the various ways that public policy is influencing, obviously, industries like ours. I think, if you take India, for example, which is a country that previously restricted remote sensing to 5.8 meter imagery, and now recently kind of brought that down to 1 meter resolution. High quality imagery wasn't available in India for commercial sale. And examples like Saru finding his family, or actual kind of economic benefits of companies that use imagery, of crisis response, of governments helping to respond to a disaster. That kind of those kinds of benefits can't happen without better remote sensing, without better base map data, and laws like the 5.8 meter restriction really kind of undermine our ability to kind of make progress in the geospatial space. So I will end with that, unless there are any other questions.
I think we could maybe open it up to questions.
Sure.